Hi students, today I am going to discuss two problems that are based on chapter 4 from your book. Chapter 4 is equivalence for a repeated cash flow. So basically this chapter talks about the problems that are modeled by the uniform series compound interest formulas. That means if you have a repeated cash flow of a repeated nature, how can you convert the whole cash flow for multiple periods? Maybe it's annual or maybe it is monthly, but the idea is to convert the repeated cash flow into its present value or into its future value depending on the problem statement, right? So let's why don't we start with problem 1. So I'm going to read this problem first and then I will show you how to solve the problem. So let's read the problem. While in college, Ellen received $40,000 in student loans at 8% interest. 8% interest, which is important. She will graduate in June and is expected to begin repaying the loans in either 5 or 10 equal annual payments. So either she will pay the loan back in 5 years or 10 years, right? Depending on which plan she goes with. So what we have to do is we have to compute her yearly payments for both the repayment plans. So if she goes for 5-year plan, we need to calculate her yearly payment, and if she goes for 10-year plan, we need to calculate her yearly payment in that case as well. Okay, so two scenarios. So last time we looked at the compound interest table and the terminology that is used in that table. So we will try to put this problem in that format. For example, do we know the present value? Yes, we do know the present value. Present value P is $40,000 in loan that she received, right? So I'm gonna write P is $40,000 and this loan, so she is graduating in June, so not to get confused, so when she graduates in June she will have $40,000 loan. That's what it means. And then from that point onwards she needs to pay it back in 5 years or she needs to pay it back in 10 years. Okay, because some students may have question, when did she receive loan? Did she receive loan during the last 4 years? No, it's nothing of that sort. It's straightforward. In the June of this year she will have $40,000 loan as its current value. Okay, so P is $40,000, which is present worth. Now we need to find out annual payments. That means we need to find out A, right? A for 5-year plan and A for 10-year plan. That we need to find out. I is given to us. I meaning interest rate. I is the value. I is given to us, that is 8%. And how about N, number of years? Yes, that is, we also know N is 5 years if for the first part of the problem, and for the second part of the problem N is equal to 10 years, right? So now let's solve this problem. I already have a solution here, so I'm just going to explain this. So let's first do the calculations for 5 years. So we write the formula. We need to find out A. P is known to us, right? P is known to us, and we need to find out this factor from the table, A given P factor. If P is given to you, what should be the factor A, right? A given P factor we need to find out, given that I and N, that's a standard form that we looked at last time. A given P comma I, interest rate, comma N, number of years, and that factor multiplied by P will give us equivalent annual payment. Okay, so we start putting in the value. P is $40,000. A given P is there, we need to find that out. I is 8% interest rate and N is 5. So next thing we do is we look at the compound interest tables at the back of the book. So I'm gonna open that here, and 8% is important, right? So we need to find out the table for 8%. This is for 0.25% or 1/4%. So if you scroll down, you will get to see 8% interest rate. So that is right there, 8% interest rate. So this table is important for us. Now in this table N is given to us. N is given to us, that is 5. right? So that n is equal to 5, and then we can start looking in the column. We are interested in uniform payment series because it's a repetitive period cash flows, right? So that's the one we are looking at, and we are specifically looking at A given P, capital, that is also called as capital recovery factor. Find A given P, right? A given P for 5 years is 0.2505. 0.2505 is that factor. So that factor goes in here, and we do the multiplication. That means if she goes for 5-year plan, she will have to pay $10,020 each year to the bank, right? So that's the first answer. Now let's see what happens if she goes for 10-year plan. If she goes for 10-year plans, the formula remains the same, except for the value of n is going to change now. It's going to change from 5 to 10, right? 10 years. Then we again go back to 8% interest rate table, right? This is the same table. Then we look at n is equal to 10, and that we find A given P factor, or capital recovery factor, is 0.1490. So we put that value there and we do the multiplication. So we get $5,960. So you can see yourself what happens if she goes for 5-year plan. She ends up spending less amount of money, right? Total, if you do the total for 5 years, and if she goes for 10-year plan, she will end up spending more money just because she is paying it in a long duration. So that was simple. That's problem 1. Now we can start solving the problem 2. This problem is little different than the problem that we just looked at. Sometimes, for example, your payments may not be annual. You may need to pay on a monthly basis. For example, your mortgage, right? You pay on a monthly basis. Or if you have purchased a car on loan, auto loan if you have taken, then you know that you need to pay on a monthly basis, right? So how can we do the calculation on a monthly basis? So we can look at that, because generally the percentage, the interest rate is given on an annual basis. So how can we break it down at the monthly level? Okay, so first let's read the problem. Suppose you wanted to buy a $180,000 house. You have $20,000 cash to use as the down payment. So the house cost $180,000, and you have $20,000 you already have for the down payment. The bank is offering to lend you the remainder of money at 6% nominal interest rate, 6% interest rate, and the term of the loan is 20 years. The loan is gonna be for 20 years. So your job is to compute the monthly loan payment. This is interesting problem. I mean, this is a real life problem. You face this type of problems every day, right? When you take a loan, or when you put money in the bank, you need to know. You should be able to calculate the values so that you know what's going on, right? So let's see. First, let's calculate the amount of loan. So amount of loan is straightforward. $180,000 is total cost of the house, and you have already $20,000. So if you subtract 20,000 from 180,000, you get the total amount of loan, that is $160,000 loan the bank is gonna give you. Now interest rate is given 6%, and when it doesn't say that 6% interest rate, it doesn't talk about the period. That means by default it's gonna be annual interest rate, right? So it's a 6% annual interest rate. Sometimes you will see problems like 6% annual interest compounded quarterly, or compounded on a monthly basis. So then you need to change accordingly. But here it just the only information we can see from here is the annual interest rate is 6%. So we need to again find out. First we need to write down the values of the parameters that we know. Which is interest rate, we know, but since we are going to talk about monthly payments, we will try to divide interest rate monthly, the annual interest rate, into monthly interest rate. So how can we do that? If we are paying 6% annually, so if we divide that by 12 months, we get 0.5% per month, right? Basically it comes down to 0.5% per month. So that is our I value. Now next is N. So we have to be consistent in our units. If we are using I per month, interest rate is per month, then N, which is number of time periods, it's not necessarily number of years, number of time periods, that should also be in terms of months. We cannot have N in years and I in on per month. We can't have that inconsistency. In formula we need to make sure that we are using consistent units. So N, which is, we know that it's a 20-year loan, so we can convert it into months. So we multiply 20 by 12, so total 240 months, right? 240 months. Now we need to find out A, that is the monthly cash payment in this particular case, because all the calculations are in months. So A is a monthly payment. That is equal to, if we use the same this formula here, we can write down the value of P, which is 160,000, which is P value, right? Total amount of loan that the bank is giving you today. Then we need to find out the A given P factor. Given that annual interest rate is 0.5 and the value of N, which is 240 months. Now let's see, can we find that factor out. So we go back to the table again, and I want to find out the A given P factor. So we need to look at the N is the I is 0.5%, right? So we need to look at 0.5% interest rate table, which is right here, 0.5% interest rate table. Now in this table you will see the N that is we have is 240. So we're gonna look at N 240. So I'm gonna scroll down. So here you can see N 240, right? And A given P, so that column you will see A given P is 0.00716, 0.00716. So that's gonna be if you multiply 160,000 by the factor, you get the monthly mortgage payment, which is $1,145.60, right? Now that we are here, I want to say one other thing. What if your monthly your N is 250? The value is not given for 250 here, right? The row is not there, or 250 or maybe 260. Then what do you do? So let's say we're talking about let's say 300. So 300 is somewhere between 240 and 360. So that means we know that the A given P factor should be somewhere between 0.00716 and 0.006. So we know that it has to be a value between these two numbers. It cannot be 0.72 because that is going out of the range. Again, it cannot be 0.005, that is going out of the range. So we have to look within the range. But how can we exactly calculate that value? So what we can do is we can do the interpolation. Interpolation is a technique that you can use to find out the values that are not given if you know the range. So that how to do interpolation, I am sure there are many tutorials on internet. You can read about it and then you can do it on your own. And right now we don't have that problem, so I'm not going to go into that. But this is just for your information. Maybe in your homework problem you may need to do interpolation. So with this, I think I pretty much covered what we need to know in this lecture. So thank you very much. See you next.